Hi, I'm George Woodbury from College of the Sequoias, and this is our last video on hyperbolas where we learn about eccentricity for hyperbolas. Similar to ellipses, eccentricity is E equals C divided by A, but now for a hyperbola, remember that C is equal to the square root of A squared plus B squared, rather than A squared minus B squared. That means that C will always be larger than A, and the eccentricity will always be greater than 1. Remember, for an ellipse, it was always between 0 and 1, but now it's going to be greater than 1. The first example, find the eccentricity of y squared over 49 minus x squared over 64 equals 1. Really important to point out that a squared is always under the leading term here, the one that's positive, not the one that's being subtracted, the one that's being subtracted from. And so here a squared is 49, not 64. And that means that a is 7. We'll need that in a minute. For b, we really only need b squared, which is 64. C is the square root of 49 plus 64, or the square root of 113. So the eccentricity is the square root of 113 over 7. Right? That's the value of A. Square root of 113 is between 10 and 11, so we can see that that's greater than 7. Our result is going to be in the 1.5 range, but definitely bigger than 1. To approximate this, let's go to the calculator. Square root 113 divided by 7. If we round to 2 places, we get 1.52. Try one more. Here I've got to get it in the right form first. I've got 81 times the quantity x plus 3 squared minus 4 times the quantity y minus 2 squared equals 324. Begin by dividing through on both sides by 324. 81 times 4 is 324, so the first one simplifies to be x plus 3 squared over 4 minus y minus 2 squared over 81. Oops, sorry. Equals 1. So we don't need the center here. We're not graphing this. But what we do need is a squared equals 4, so a is 2. B squared equals 81. C equals the square root of a squared plus b squared. Always tempted to write the square there for c like it's the Pythagorean theorem, but it's not. So c equals the square root of 4 plus 81, or the square root of 85. That's a little bigger than 9. The eccentricity is the square root of 85 over 2. That's going to be bigger than 4. It's going to be somewhere between 4 and 5. So much bigger here. Let's calculate that out. Square root 85 divided by 2 is 4.61 to 2 places. All right. So that's how you find the eccentricity for a hyperbola. What I suggest you do is try graphing those two hyperbolas and see what happens as the eccentricity jumps from 1.52 up to 4.61. Take a look at how the graphs change. All right, that's it for hyperbolas. I'll see you in the next section.